one of the development engineers here at Norco. I spend a ton of my time working on suspension, and today I'm going to be walking you through our approach to frame kinematics. Let's get into it. So we have a goal here at Norco to be #1 in ride quality, and we focus an immense amount of time testing bikes in the environments that we want them to excel in to try and achieve those ride quality goals. Suspension is a key component to achieving that ride quality, and really what we're trying to achieve is a sense of confidence that comes from a sense of control. We have the best experiences on our bikes when we feel confident and in control no matter what the trail is going to throw at us. And so that's always what we're trying to achieve from a different suspension design. For different applications, we pick different suspension layouts. That allows us to really tailor the suspension kinematics around what we want that bike to excel at. Axle path is one of the keys to our suspension story. Really what we're looking for from axle path is the ability to tune how rearward the axle path is so that we can tailor it around different applications. And the reason we want to do that is as trails get rougher, trail speeds pick up, you get more of those square edge impacts that are really acting to knock you offline and slow you down. Having some increased rearward axle path allows the rear suspension to better absorb those impacts, translates into more motion of the rear suspension and less force acting to slow you down. And ultimately that just kind of feels like this greater sense of control and confidence in those rough situations. Different layouts allow us to achieve different amounts of rearward axle path. And that's really one of the keys to our suspension story, is picking the suspension layout that allows us the range of axle path that we want for that application. VPS refers to virtual pivot suspension, and it's Norco's take on that traditional horse link suspension layout that we've been developing for years. In this layout, the rear axle is mounted to the seat stay along with the brake, and the seat stay is connected to the front triangle with the chainstay and the upper link arm. And what makes this a virtual pivot suspension layout is the fact that the rear axle doesn't rotate around any fixed point on the front triangle, but it instead rotates about a virtual pivot point that's dictated by the upper link arm and the chainstay, and that offers a couple benefits, one of them being greater levels of control over axle path, which with this layout is typically vertical and transitions to forward deeper in the travel. And it also offers greater control over anti-rise versus something like a single pivot layout. And anti-rise simply refers to how the suspension responds when the brakes are applied. The upper link in this design, in addition to controlling axle path, also compresses the shock. And that gives us greater levels of control over the leverage rate of the bike and the amount of progression from the leverage rate. And so we can tune that through mule testing to work well with different shock specs, whether we're speccing coil or air shocks, and different damper tunes to ultimately all contribute towards our overall ride characteristic. The VPS suspension layout is well suited to light to moderately technical terrain with equal emphasis on climbing and descending. It offers up plenty of traction when needed while still being efficient when putting the power down, all in a simple and lightweight package. The VPS HP layout is the next evolution of our years of developing VPS suspension platforms, and it shares a lot of the key benefits of that VPS suspension layout. But one of the key differences is what we've done with the main pivot. So the main pivot now sits higher on the front triangle and higher relative to the rear axle. And that's what's allowed us to achieve an increased amount of rearward axle path with this layout. Axle path is still defined by the chainstay and the upper link, and the axle is still mounted to the seat stay along with the brake. But in this case, with the higher main pivot, we have a more rearward axle path, and we can tune how rearward that axle path is. One of the effects of increased rearward axle path is an increased amount of chain growth. And that comes from the rear axle moving further away from the bottom bracket as the rear suspension is compressed. And the way that we minimize the amount of chain growth so that we can minimize the pedal kickback or feedback through the rider's feet that can come as a consequence of that is by running an idler that allows us to reroute the chain around a point that reduces chain growth through the suspension's travel. We've taken this one step further by incorporating an iTrack feature that allows us to offset the idler from the main pivot, so we can move the idler location relative to the main pivot, and that allows us to fine-tune the anti-squat characteristics of the bike so that we can give different bikes different personalities just through idler location, and we don't actually affect other kinematic traits. So that's a really unique benefit of this type of arrangement that you don't really get from bikes that don't use idlers and can't control the location of that idler. And it's one of the things that's allowed us to give the sight and the optic to different personalities despite looking very similar and using the same suspension layout. A lot of the other benefits of the VPS layout carry over to VPS HP. One of those is our greater level of control over anti-rise. In being able to better control anti-rise through controlling where the instant center sits, and allows us to reduce anti-rise while keeping a more rearward axle path, so that we can balance the need to counter rider weight shifts to the front wheel when you're hard on the brakes with the need for the rear wheel to track and not pack down in rough sections of trail. The upper link in this arrangement, it gives us a nice consistent rate of progression from the leverage curve. And through mule testing, we can tailor the amount of progression that we want to suit different application to always achieve that kind of balance of compliance and support. We can also tailor that progression around different shocks, whether we want the ability to run coil and air shocks, and also different damper tunes. So it's kind of all those characteristics that come together to give the bike an overall ride characteristic. The VPS HP layout is well suited to riders looking to push their limits in demanding terrain and looking for the added confidence that a rearward axle path gives them, while at the same time wanting their bike to respond well to rider inputs and ultimately just feel intuitive like an all-mountain trail bike should. And that's what the VPS HP layout delivers. HVP 6 stands for High Virtual Pivot 6 Link. And this is the next evolution of our successful high virtual pivot layout that was used on the Range Enduro race bike. This layout builds on a lot of what we learned from developing the Range and then racing that bike with our factory riders, both for enduro and for downhill, over the last 3 or 4 years. We've tried to keep all of the benefits of that HVP layout with this new HVP 6 layout. So those are continuing to define the axle path about a virtual pivot point that's determined by the seat stay and the lower link that connect the chainstay to the front triangle. And the rear axle and brake are mounted to the chainstay in this case. And one of the key benefits of that is we can achieve the greatest level of rearward axle path with this layout. Really well suited to those most demanding applications, the roughest, largest impacts, and highest speed trails. So obviously why we've selected it for our new downhill race bike. As with all of our bikes that have an increased amount of rearward axle path, we use an idler to control the amount of chain growth that can come along with that. Similar to the VPS HP layout, we're able to tune the pedaling characteristics and also the amount of feedback or pedal kickback through the rider's feet by changing the idler's location to alter the amount of chain growth. So we can mount that in different points relative to the main pivot to tune that balance of pedaling versus feedback through the feet. One of the unique things about this layout that we wanted to carry over from the Range is the anti-rise characteristics that can be achieved. So we can have a fairly high level of anti-rise around ride height to balance weight shifts when you're hard on the brakes. But under deeper compressions, we can significantly reduce anti-rise and allow the rear wheel to recover from deeper impacts and get back to ride height without packing down. One of the key differences between this layout and the HVP layout used on the Range is the introduction of 2 additional links that are dedicated to compressing the shock. And what that allows us to do is to tune the leverage curve to a greater degree in isolation of all of our other kinematic traits. So we can now define leverage curve shape and progression, and we can tune that without affecting anything else. The HVP 6 layout represents the cutting edge of Norco's suspension development technology and is best suited to the absolute most demanding applications, the highest speeds and roughest terrain out there, and it's exactly why we've picked this as the layout of choice for our new downhill race bike for the Norco factory racing team. That covers a lot of the details in our approach to suspension design. Head over to norco.com if you're looking for more info.